Thank you. Hello all. Welcome to the AI in the Data Center webinar today. My name is Viswateja Nemani and I am a product manager at Achronix, handling our AI and software solutions. Achronix is a semiconductor acceleration company that offers high performance FPGA solutions. I will touch upon the company and its offerings at the end of this presentation. This webinar intends to explore the inner workings of high-performance computing in data centers, with a special focus on the pivotal role of field programmable gate arrays or FPGAs and their design distinctions from traditional computing systems. AI, ML, DL. These are some terms you probably hear a lot in recent times, interchangeably too. What do they actually mean though? AI is a branch of computer science focused on the development of machines which emulate human behavior. These machines range on a spectrum from simple execution of an algorithm to learning from the environment and adapting their algorithms with no human intervention. Machine learning is a subset which uses statistical models derived from datasets to improve specific tasks. As a subset of machine learning, deep learning leverages multi-layer neural networks to not only perform basic machine learning inferencing, but is of learning from new data, yielding a higher level of cognitive ability. Think of this as similar to a human brain. Now that we have seen the differences between the terms used in the industry, let us now jump into the topic for today: AI in the data centers. Almost every industry is looking to add AI functionality that will streamline processes, improve performance, and provide predictive and data analytics. Data centers are uniquely positioned to support AI applications because of their extensive infrastructure setup. They already have systems in place to handle high performance computing and high bandwidth applications. Data centers are also poised to handle AI workloads that require a higher amount of power and liquid cooling. With the use of specialized accelerated hardware such as FPGA and GPU cards in their server systems, they also help process vast amounts of data very fast. Now that we have seen how data centers are ideal to support AI applications, let us take a look into how AI can be utilized in the day-to-day operations of the data center itself. An area where AI/ML is most useful is to spot patterns in data. Some of the benefits of doing this are listed below, and I will go through each of them in the upcoming slides. AI can be used to optimize a data center's energy efficiency by doing the following things. First one is by proactively managing the power usage effectiveness and assessing the impact of the operating parameters of the systems. Second is by identifying the best set of operational parameters to minimize the energy consumption. AI can also be used to predict and optimize the effectiveness of water cooling so as to operate the data center optimally. When we talk about analytics, there are majorly four different types, and they deal with what happened, why did something happen, what is likely to happen, and how will this happen. In the context of this presentation, I will only talk about the last two types, which is the predictive and prescriptive analytics. Predictive analytics uses statistics and modeling to proactively predict what will happen next. It identifies trends and patterns in data. Prescriptive analytics, on the other hand, uses both machine learning and big data to identify what action to take, what actions to take. Both of these methods are capable of automating and streamlining the day-to-day operations of a data center. By incorporating these methods, we see that we can we can have real-time improvements to cooling systems, power, and rack space allocation, and therefore can drastically lower the operating expenditure. You can also use these analytics to make use of dynamic workload management and allocation by routing the most computational tasks to the most efficient resources in real time, thereby reducing the costs and improving customer experiences. AI can also be used to spot issues before they happen, drastically reducing the downtimes and providing a high level of service, thereby uh, reducing the workloads of the IT staff. Another major area where AI can be utilized in the data centers is in the field of security. As we know, cyber threats are constantly evolving and are relentless. Traditional security measures may be too slow to learn new threats and implement the defense mechanisms that are effectively needed to counter these threats. The data center AI can offer solutions such as anomaly detection, wherein you monitor the network traffic, access the logs, and the overall system behavior to show if there are any deviations from the norm and lock down systems and protect them as needed. Proactive security measures, when compared to traditional reactive security measures, tend to seek out potential threats and vulnerabilities before they can even be taken advantage. This is also called as advanced threat detection. Also, by protecting the data using AI, we can improve the data processing, storage, and security aspects of any data. All of the applications that I have previously mentioned require large compute systems that can process vast amount of data with low latencies. This is where field programmable gate arrays or FPGAs shine because they can run in real time and process and have in-network compute capabilities to help applications such as automatic speech recognition, which I will talk about in my later slides. FPGAs are incredibly helpful in real-time monitoring and analytic systems to improve efficiency of the data center. They also can help you stay ahead of any new threats or constantly evolving market opportunities due to the reprogrammable nature. They can host multiple applications and be scaled, thereby helping minimize the total cost of ownership to the user. How can Achronix help the AI in the data centers? Achronix offers a high-end FPGA called a Speedster 70, which can be used to adapt to evolving AI workload demands. With its unique machine learning processor and 2D NOC inbuilt into the architecture, it is optimized for AI applications. When compared to typical CPU and GPU solutions, Achronix Speedster 70 generally offers 30% reduction in power when compared to the GPU and around 15 to 20 times higher processing performance when compared to a CPU. Now that we have seen how and AI can be used in the data centers and how FPGAs can help this AI workloads, let us also take a brief look at the kinds of AI workloads that are generally run in the data centers. Training AI models is the most common workload that is that is done in the data center. There are dozens to thousands of GPUs or FPGAs in, in the data centers that are required, and the AI resource allocation helps manage these scaling scenarios. Also, in the last 1 to 2 years, we have seen an explosion in large language models or generative AI applications, and these require a great, a great deal of compute power, not only to train but to run inference. The latest models are over 1 trillion parameters. Other applications are traffic routing, object detection, governmental agencies that will need to sift through petabytes of data looking for any malware activity. And an interesting application of all of this that I will touch upon a little is the conversational AI side of things. So think of Siri, Google Home, Alexa. All of these fall under the conversational AI branch. So, what exactly is conversational AI? In short, it is interacting with computers as if they were human. There are typically three stages that make up a conversational AI system. The first stage is the automatic speech recognition or ASR stage, where the, the system is capable of converting spoken language into readable written text. And in many speech AI systems, the output of this ASR is then fed into a natural language processing model that helps transcribe the output with proper punctuation, capitalization, and things like sentiment analysis, text analytics, text summarization, and question answering. For certain applications, such as language translation, the output of the NLP stage is then converted back into speech using a text to speech algorithm. Let us now look at how an Achronix ASR solution can help benefit customers. FPGA-accelerated AI speech recognition combines the hardware benefits of FPGAs with the software benefits of easier programmability. Our solution is a real-time appliance running the software stack from a partner called Myrtle jointly on a server class CPU and our vector path accelerator card, which has a Speedster 70 FPGA in it. And all of this is presented to the customer in the form of a simple WebSocket API, which, which abstracts away the fact that there is an FPGA in the system. So in the figure here, I show an 8 card server system, and please note that each card is capable of running 2000 real-time streams. So this provides a 90% reduction in end-to-end latency for real-time voice ASR customers, since our appliance only takes around 50 milliseconds end-to-end to, to run the whole process. This almost has a 15 times higher throughput than a GPU and a 20 times higher throughput than a typical CPU. So to put this into context, assume a 15,000 seat stadium and you would only need a single 8 card server appliance to transcript all the audio streams coming in from that stadium. Competitive solutions are typically GPU based, and here I have taken the example of an A5000 GPU to do the comparison against our Achronix Speedster 70 solution. This is the total cost of ownership for 64K voice channels, assuming a growth of 25% per year. As you can see, the Achronix solution provides 20% better performance per dollar than GPU-based solutions, saving millions of dollars per year in both operating expenditure and capital expenditure. Now that I've spoken about how AI can be used in the data centers and what FPGAs are, let me quickly dive into the Speedster 70 solution that I've been talking about so far. So our Speedster 70 FPGA is a high-end FPGA built on TSMC's 7 nanometer FinFET process. It features a revolutionary 2D knock and an array of machine learning processors which are optimized for high bandwidth and AI and ML workloads. The high bandwidth GDDR6 interfaces, along with the 400G Ethernet and PCIe Express Gen 5 ports, are all interconnected to deliver ASIC level performance while retaining the full programmability of FPGAs. Speedster can not only do machine learning, but it can also cluster data and process massive amounts parallelly. Here are some of the other solutions that Achronix offers. So I briefly spoke about our Achronix Speedster 70 solution in the previous slide. So along with a standalone FPGA, we also offer an embedded FPGA solution, which which is a custom FPGA that you can embed into any standard SoC or ASIC. So we have already shipped over 15 million cores of this sample, and we are the industry's only silicon proven high density, high performance eFPGA IP. Another product line that we currently have is our accelerator card product line, which is the vector path accelerator cards. The vector path is designed to reduce time to market when developing high performance compute and acceleration functions for AI, ML, networking, and data center applications. The card features the Achronix's high performance Speedster 70 fabricated on the same 7 nanometer FinFET technology. And to support all of these cards, we also have a world-class tool suite called the Achronix tool suite. Please let me know if you have any questions, and thanks a lot for attending the webinar. If you have any other questions, please feel free to contact us via the link that I've shared below. Thank you.